All right, my people, we are here again for Mathematics Meal, where we feed people mathematically so that they will not suffer mathematical kwashiorkor. So many people today are actually suffering from mathematical kwashiorkor just because they have not taken balanced diet in mathematics. Here, we give you balanced diets. All the aspects of mathematics are covered. All aspects of mathematics are covered in this particular program. Once again, welcome to Mathematics Meal. Today on Mathematics Meal, we are still looking at plane geometry 1. We have looked at the preliminary part of plane geometry 1, where we saw lines and angles. And then we look at the valid points or valid relationship between lines and angles, where we saw that sum of adjacent angles on a straight line is 180, sum of angles at a point is 360. Then we say when we have intersecting lines, vertically opposite angles are equal. We also say that when we have parallel lines and transversal lines, their corresponding angles are equal and alternate angles are equal. There is need for you to watch the videos that cover the preliminary aspects of plane geometry 1 on our YouTube channel, Mathematics Meal 1, or on our Facebook page, Mathematics Meal. You can also contact us through our WhatsApp, then give us your email. We can forward our videos to your email address. One thing is important: the more you feed on mathematics, the healthier you become in mathematics. All right, we want to solve equation still on plane geometry 1 as it concerns angles on lines. So calculations involving angles on lines. Remember, we have already given the valid relationship that exists between angles and lines. So we have a figure. We have to find the lettered angles in the figure below. All right, so we have this. All these are angles that we need to find. We're given just one. Now, we say when we have angles on lines, the first thing we do is to take note of the given angle, that's the known angle, and then we also take note of the unknown angle or unknown angles. In this case, we have unknown angles. There are so many of them. Then another important thing that we must not fail to do is to look for connectors. That is what connects the given angle, that's the known angle, and the unknown angles. You must establish a relationship. You cannot just start doing anything. There must be a relationship between them. You must establish that relationship between given and the unknown what angle. So the given angle here is angle 67 degrees. So we must establish relationship between this angle and all other angles that we are required to calculate here. So in doing that, remember the valid relationship that exists between lines and angles. Angles on a straight line, the sum of adjacent angles on a straight line is what? Is 180. Sum of angles at a point is 360. Vertically opposite angles are equal. Then using parallel lines, alternate angles are equal and parallel line, corresponding angles are equal. Now, if we look at this line is parallel to this line. Someone will say, how do I know? The arrow. In our video, when we treated lines, we say that we identify parallel lines by these arrows. The arrows indicate parallel lines. So one arrow here, one arrow here. So this line is parallel to this line. So in this figure, we have a parallel line. So let's see whether we have a transversal. Yes, we have. Any line drawn across parallel lines, we call it what? A transversal line. So we have parallel lines and transversal lines. You look at that. So there is possibility for us to talk about corresponding angles and alternate angles here, because we can only talk about corresponding angles and alternate angles when it concerns angles on line, when we have parallel lines and transversal lines. So I have a transversal line that have parallel lines. So there is possibility of talking about alternate angles and the what? And corresponding angles. All right. Now, if you look at this line is also a straight line. So I can talk about adjacent angles on a straight line. You see that? So this straight line, this is a straight line. So if you look on top of it, there is a straight adjacent angle there. Under it now, we have adjacent angles also. So this one also is a straight line. So I can talk about adjacent angles on a straight line. Adjacent angles on a straight line. You see that? So this transversal line also is a straight line when you look at it like this. So this and this can be taken as adjacent angle on this straight line. This and this are also adjacent angles on this straight line. You see that? The same thing along here. This and this can be taken as adjacent angles on that straight line. This and this can be taken as adjacent angles on that straight line. So we are just trying to identify the possible valid relationship that can exist in this figure, so that we will now know the ones we use for our calculation. Then you can, if you look at this, you look like X, intersecting lines here. That means whenever we have intersecting lines, we can talk about vertically opposite angles. So we have done a lot to interpret this diagram. So what remains now is for us to carry out our calculation. Okay, let's begin with the calculation now. We have this. Which angle can I easily find now? I have 67. Does 67, I have this unknown, M, N, and P. Does 67 have any relationship with M? Does it have any relationship with N? Does it have any relationship with P? Somebody will say, oh, this angle at a point. No problem. If you do that and say M plus N plus P plus 67 is 360. Sum of angles at a point. Okay, but the only known values here is 67. So how will I possibly find M, N, and the word P? You see that? That's why we will not rush to that sum of angles at a point. But if we look at this, we can easily find N. Do you see that? I can find N because N and 67 are vertically opposite. You look at the intersecting line. You see that? So I can easily say that N is equal to 67 degrees. N is 67 degrees. Why? They are what? Vertically opposite angles. Remember, we said that angles that are vertically opposite are actually what? Equal. Okay? I found N. Then look at 67 and the M. You know, they are angles on a straight line. You look at that, 67, this is a straight line. This line now is straight because you can draw a semicircle from there landing on that at that point. So it means that if I add M and 67, it's going to give me 180 degrees. Why? Sum of adjacent angles on a straight line. The sum of adjacent angles on a straight line is 180. So it means that M will be equal to 180 minus 67. 180 minus 67. When 180 subtract this, I'm going to have 113 degrees. Okay? We go again. I found M. I can actually get P. It's either I say that this plus this will give me what? 180. Angle on this straight line. Because this is a straight line. So under this, I have angle on the straight line. Or I can say that M and P are equal. I have found M because they are vertically what? Opposite angles. So I can say that P is equal to M, which is equal to 113 degrees. Reason they are vertically opposite angles. Oh, beautiful. Beautiful. Still on the figure, we are through with this. Now let's talk about alternate angles, corresponding angles. Now, you know, this is a parallel line of its own. So I can start relating this parallel line with this parallel line. The two of them are parallel lines. So I will relate this line and this line because they are parallel now. This is a transversal. Now look at arrow and 67. What can you say about arrow and 67? We can actually say that arrow is equal to what? 67 degrees. Why? They are what? Alternate angles. We say that alternate angles occupy different sides and different positions. This one is on the left, this one is on the right. On this parallel line, R is on top of the line, while 67 is under the line. So different position, different size. Under the line, on top of the line, on the left, on the right. We call them alternate angles. And we say that alternate angles are what? Equal. There are so many ways of finding all this. You know that this R now is the same thing as N. They are corresponding. On this line, N is on top, R is on top, and two of them are on the right. So the same position on the same side. So they are corresponding. So one can still say R is equal to N. And what is N? N is what? 67. In this case, corresponding what? Angles. You see that? Okay. Then I can get X. Look at X and 67. One can still get S by saying that R and S are vertically opposite. So if I don't want to say R is equal to S is equal to R, I can say X is equal to R, which is 67 degrees. Reason they are vertically what? Opposite angles. They are vertically opposite angles. Another person will say, okay, since I found R, that's why I have to do this. Another person will say, after all, 67 and X are what? Are corresponding angles. Because here, 67 is on the left and is under the line. X is also under the line and also on the left. So they are corresponding what? Corresponding angles. So one can still say directly S is 67. That this S is equal to this 67. We didn't change the value. You see that? Because they are corresponding angles. So if you know all these valid points, valid relationship, you will not find it difficult trying to solve problems involving lines and what? And angles. And if I have found R, and I have found X, I can equally find Q. You notice that R and Q are angles on a straight line. Or one can still compare M and Q because I have found M already. But let's use R and Q. I can say that R plus Q will give me what? 180. Sum of adjacent angles on a straight line. Sum of adjacent angles on a straight line. So what is R? We have found R to be 67 plus Q will give us 180. So what will be Q? Q will be 180 minus 67. Q will be 113 degrees. 113 degrees. That will be Q. It will still be the same thing if someone decides to compare M and Q. They are corresponding angles. We have found M to be 113 degrees. So M is still corresponding to what? To Q. So they will be equal. So Q is still 100 and what? 113. Another person may say, let's find it using alternate angle between P and Q. Q is alternate to P. And if you look at P again, P is 113. So you still see it's going to be 113. And now that I have found Q, I can find T because Q and T are vertically opposite angles. So they will be equal. So T will be equal to Q, which is 113 degrees. Reason they are vertically opposite angles. Oh, beautiful. Beautiful. This is very simple. We are not yet to start looking at the major thing. There are questions. There are questions that will look more complex than these ones. Yeah, will look more complex. Where we now need to do some little construction in order to actually establish a relationship between the unknown and the what? And the known. All right. We shall be back because we need to take a break. We shall be back. And when we come back, we'll continue with other examples. Remember, our interest is to feed you properly so that you will not be suffering from mathematical kwashiorkor or mathematical malaria. We want to give you a balanced diet in mathematics so that at the end of the day, you will look very healthy in mathematics. All right. Continue to enjoy mathematics meal. But remember, we shall be back to continue with plain geometry. When we return, we will look at example 2. Thank you, and God bless you.